Hi dear students, how are you? I hope you're fine. Today we're going to have a new lesson. It's about the functions and a new unit 2. So chapter 8, functions and graphing. Today we're going to talk about the functions. Okay, a relation. A relation is a set of what? Of ordered pairs. The set of the first coordinates is the domain. The set of the second coordinates is the range. So this is very important to know. The set of the first coordinates of x, it's the domain, and for y, it's the range. So you can model the relation with a table and a graph. Okay, let's see a table or a graph. Okay, this is our graph as you see here. So the definition of a function is the relationship between each element in the domain, okay, that's paired with exactly one element in the range. Okay, guys, you can use the vertical line test to test whether a relation is a function or not. Let's see. We have here what the question comes like that. What are the domain and the range of the relation graphed here at the right? Is the relation a function or not? So the set of order pairs for the relation are what, guys? The order pairs for the points given. The first one is what? 1, 2. So it will be 2 and what? 2 and 1, 2, 3. So this point, it's 2 and what? And 3. What about this point? It's what? 1, 2, 3 and 2. This second point, it's 2, it's 3 and 2, it's 3 and 2. Okay, after here plotting or writing the points given to you, okay, so he asks me what to say the domain, and we have also 0 and 0 here, this at the origin. Don't forget this is at the origin. And the third one here, it's 4 and 2. We go here 1, 2, 3, 4 and 2 up. This is 4 and 2, and this is 0 and 0. After plotting all the, after here defining or writing all the order pairs of the given dots here, I want the domain, the x axis here. So it will be 2, 3, 4 and 0. So these are our domain. The range is what? The range for the y coordinates. So 3, 2, 2 repeated, so write just 1, 2, then 0, 3, 2, 0. This is very easy. Remember, domain for x and range for y. Since no vertical line passes through here, we don't have here any vertical line, okay, any vertical lines, okay, or any here any vertical lines. So there is no vertical line passes through more than one point on the graph. For x values, the relation here is called function. So the relation here is called, this one is called function. Okay, guys. So let's have some practice, guys, here. Express the relation shown in each table or graph as a set of ordered pairs, or state the domain and the range of the relation, then determine whether the relation is a function or not. So let's have here for number 3. So in this one, I have here the order pairs 0 and 3, negative 1 and 4, negative 3 and 9. Then after that, I say the domain is 0, negative 1 and 3. Then this is the domain, and then the range will be 3, 4, then 9. Okay, this is easy. What about this one? First of all, we got the points from the from the coordinate plane. I have here what? Let's write them together now. So okay, guys, so we got here we have here negative 2 and 3. So let's do it step by step. I have here this one, it's 1 and 1, 2. We have 1 and 2, this point. We have also 1, 2, and then we have negative 1, 2 and negative 1 for this second one. We have here negative 1 and negative 1, negative 1 and negative 1. We have also negative 1, and then I go up 1, 2, 3. So negative 1 and 3. And we have negative 1, negative 2, negative 2, and 1, 2, 3, negative 2, and up 3. So we have here, as you see, negative 2 and 3. We have here negative 1 and 3. We have here negative 1 and negative 1, 1 and 2. Okay, after doing so, I write the domain for x-axis. I write the domains for x-axis, then the range for y-axis. Okay, guys, is it easy now? I think it is. Okay. And don't forget to tell that this is not a function. This is not a function. The relation is not a function, as we can't do here a line to connect the dots that we got. Okay, we got here another question. What's the range of this relation? So the range we are talking about here, the y coordinates 9 and 12. So the answer will be B, 9 and 12. So now let's have another lesson. It's the linear equations in two variables. This is a very interesting one. So let's start together. Solving an equation means finding what? Finding replacements values for the variable that make the sentence true. An equation like here y equal to x plus 3 is a linear equation because its graph is a straight line. The solution of this equation with two variables are ordered pairs. An equation with two variables usually has infinite number of solutions. So let's see now what I'm talking about. If I have here this example, my dear students, okay, so in this example we have find four solutions for the equation 2x plus y equal 3, then graph the equation. So I'm going to choose for x, four variables, four values. We will choose four values for what? For x. And then substitute the values that I got. Okay, let's see here by steps. I choose the values for x, for example, negative 1, 0, 1, then 2. Okay, for each one I will substitute negative 1 instead of what? Replace negative 1 instead of x. So I have the original equation to x plus y equal 3. Instead of x I will put negative 1 and then solve for y to get the value of y. 2 times negative 1 gives me negative 2 plus y equal 3. Negative 2 will go to the other side, will be what? 2 plus 3 equals 5. So the first one will be, if here x will be negative 1, so y will be what? Y will be 5. So this is the first order pair. Okay, and we will do the same for the second. If the value of x is 0, 2 times x here is 0, okay, plus y equal 3. 2 times 0, 0, plus y equals 3. So you got here y equal 3 with x 0. So here 0 and 3. Doing the same here, 2 times 1 plus y equal 3, 2 plus y equal 3. So here y equal 3 minus 2 gives me 1. So if here 1 and what? 1 and 1. And the fourth one we've got here 2 times 2 plus, okay, plus y equal 3, 4 plus y equal 3, 4 here. So we got here negative 4 plus 3, it gives me negative 1. So with 2, negative 1, 2 and negative 1. So there are here the four values we've got: negative 1 and 5, 0 and 3, 1 and 1, 2 and negative 1. After writing them, please graph them. Put them on the graph. Negative 1 and 5. So we move here negative 1. Negative 1 means what? Negative 1 means this side. Negative 1 and 5 go up 5 until this. So this is a point. We have here 1, 2, 3, 4, 5. Then we've got here what? 0 and 3. So 0, then 1, 2, 3. This is the second point. Then 1 and 1. Then 2 and negative 1. Okay, guys, so after putting them here, we draw the line connecting them. We draw the line connecting them, as you see. Okay, guys, is it easy? I think it is, right? And it's interesting too. Okay, he asks me which of these ordered pairs are solutions. Okay, I want to annotate to make it, okay, this one. Which of these ordered pairs are solutions of x plus y equal 8? So what do you think, guys? What plus what gives me 8? Here, for sure, what? What if I substitute 4 for x and the other one for y? 4 plus 4 equal 8. So I think this is the solution, right or not? And also, if I look at this one, it will be 7 plus 1 gives me 8. Also, this is okay. And we said this is okay. What about this? Negative 3 plus 11. Negative 3 plus 11, 11 minus 3 gives me 8. And this will be right. But if I say here for CT, sorry, 2 minus 9, this will give me negative 7. So this is not a solution, but the other three are right. Okay, and he gives you here which of this order pair is a solution for the given equation. Please do this as homework. It's very easy. Okay, guys, let's continue. Okay, let's move to another lesson now. Here we have graphing linear equations using intercepts. This is very interesting. Here, 1, 2, let's complete. The x-intercept for a linear graph is the x-coordinate. Okay, guys, I need to explain this to make it easy for you. X-intercept, this is the x-coordinate. The x-intercept for the linear graph, this is the x-coordinate of the point where the graph crosses what? X-axis. Okay, and can be found by letting y equal 0. Let's see. So when I say here x-intercept, so let here y be 0, and it's here where the graph crosses x-axis. What about the y-intercept? Also make here x what? Make letting x equal 0, and the graph crosses the y-axis, the same. Let's have some examples to make sure we understood. We have find the example says that find what? The x-intercept and the y-intercept for the graph of y equal 4x minus 2. Then graph the line. Let's see. I have here, we said what? Let y what? Let y equal, I can hear you, 0. Bravo. So we have here 0 equal 4x minus 2. Minus 2 will go to the other side by which sign? Positive. So you've got here 4x equal to divided by 4, not 2, divided by 4. Bravo. So we've got here x equal to over 4. It's what? It's half. So here the x-intercept equals to half. Okay, guys? What about here the y-intercept? Let x be 0, the same as what we did for y. And then we say y equal 4. Instead of x, I will put 0. 4 times 0 minus 2. So y equal, this is 0 minus 2, so y equal negative 2. So the y-intercept here is negative 2. And you have the x-intercept is half. So you've got here, remember, what and what? Half and negative 2. We've got here half and negative 2. Okay, guys? So he asks me now to draw the line that contains them. Graph the ordered pairs, okay, for each intercept, and okay, and then we have here the intercepts are half and negative 2. And then draw what? And then draw the line that contains them. Okay, but remember we have here half and what? For x here half, we said that y is 0. Don't forget to do it like this. And the other point is what and what? The other point is negative 2 for what? Negative 2 for y. And here the x-intercept was 0. So half and 0 for this part, and this part is what? 0 and negative 2. So if I have here the drawing, I will say half is 0.5. Remember, half is 0.5 to know in the number line. So we go here half 0.5, okay, and I'm not going to go up, and I'm not going to go up here the same. And for y, I will say what? 0 and negative 2. So 0, then go down to negative 2, this point, then draw the line containing them. Is it easy, guys? I have here another one. Graph the equation y equal this one, guys. y equal negative 2x plus 3. So as we said, we have two here, two things that we're going to do: x-intercept, y-intercept. When I say x-intercept, let y equal 0. So 0 equal negative 2x plus 3. Okay, guys, so I have here positive 3 will go to the other side, okay, by negative sign. Negative 3 equal negative 2x divided by negative here 2 divided by negative 3. So you've got here divided by negative 2 divided by negative 2, the same. So negative 2 will go with the negative 2, and we have got here 3 over 2. Okay, 3 over 2. So x equal 3 over 2 means, that means what? 1.5. 3 over 2, as you know. Here, 3 over 2 improper is 1.5 as mixed. Okay, okay, so this is for what, my dear students? This is for this is for the x-intercept. It will be 1.5, and remember to put the 0 here for the y-intercept. The first part. The second part will be the same here steps. Let here x, we need the y-intercept, x be 0, so y equal negative 2 multiply 0 plus 3. So y equals 0 plus 3, y equal 3. Y equal 3 and x equals 0. X equals 0, so x-intercept 0, and you have 3 for y. So we will draw it 1.5 and 0. 1.5 means here 1, then go half, and then 0 be this on the same, okay, line of the x coordinate. And then we have got here for y 0 and 3. 0 and go up 3. This is 0 and 3. Okay, guys, draw a line containing them, then it will be graphed easily. Okay, and very easy way. You have here some practice. Do it please as homework, and send me on Google Classroom if you have on the new system if you have any problem. Now let's complete here the slope. This is the last lesson in our week. So the steepness, if I'm talking about the slope, slope is what? The steepness of a line can be expressed by as, okay, the slope, guys, is the ratio between rise and run. Okay, so rise and run. Yes, when I say rise, so I'm going to change here. This is the vertical change. Okay, guys, up or down. Vertical change means up or down. This is the rise. Over what? Over run. Run means what? Right or left. So rise, up and down. Run means right or left. Okay, guys, so let's have here the rule. The rule is very easy. It's the ratio between rise and run. This is the slope. Okay, guys, so if he asks you find the slope of the line that contains the points here 25, 2 and 7 and 4. So the rise over what, guys? The rise over run. Okay, second coordinate here we have here what? We have here x sub 1. Okay, and this is y sub 1. This is x sub 2, y sub 2. Okay, so we say what? We say here the second y coordinate, and we can say it by what? Y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. This will be easier for you, easier than that. Okay, and this note is, or the note that the order is very important, guys. Okay, so we got here what? We got here 4 minus 2 all over what? 7 minus 25. Okay, then it gives you here 4 minus 2 gives you 2. 7 minus negative 5. 7 minus negative 5 means 7 plus 5, it's 12. Okay, so divided by 2, 1 over 6, and this is very easy. So remember, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1, rise over run. Okay, guys, here he asks you determine the slope of each line named below. Okay, guys, this is very easy. Please concentrate with me on the graph. This one, how can I get here the slope? Okay, we've got here what? As you see, this point, okay, this point, and what? And this point, starting and ending. Okay, so we got here how many? So we have here, find the slope of the line that contains each pair of points. Here I have here this one. Remember to put x sub 1. Okay, make it more clear. Here remember to put here x sub 1. Okay, and here y sub 1, x sub 2, y sub 2, y sub 2. So I'm going to say y sub 2 minus y sub 1, 4 minus 9, then 2 minus 3, then 2 over 2 minus 3, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is the rule. Let me write it for you to make it clear. Okay guys, then I have here negative 5, here I have negative 1. Negative 5 divided negative 1 gives me just 5. So the slope here is, okay, 5. Okay guys, I hope you understood this too. If you have any question, please send me on Google Classroom. Have a happy weekend.